In this lesson we're going to look at how to integrate more than one term at once. So here we have the integral of x squared take away x to the minus 4 dx. Now, as with differentiation, when you're differentiating more than one term, you just differentiate each individual term at once, and you do this as well. Now this next line I wouldn't write again, I would just actually integrate them without doing all this, but I'll show you here what we mean by integrating each term. So you integrate x squared with respect to x, you take away the integral of x to the negative 4 dx with respect to x. But as I say, after this screen, if I was doing it again, I would just integrate this, add 1 to the power and divide, and then move on to the next one without writing the integration sign every time. So integrate the x squared, you add 1 to the power and divide, so that's going to be a third x cubed. Then we're going to add 1 to the power here, so that's going to be negative 3, and then we're going to divide by negative 3, so it's going to be negative a third. So take away negative a third becomes plus a third, x to the negative 3, and then plus your constant. Finish that off by taking your power underneath to make it positive, plus your c. So that's, remember, that's 1/3 multiplied by 1 over x cubed. So the x cubed goes in the bottom. Same idea here, integrate each individual term, but as I said previously, after this you don't write the integration sign every time you see a term with respect to x every time. So add 1 to the power and divide, so that's going to give us 1x cubed. Add 1 to the power, so that's 1/5 plus 5 over 5, that's going to go to 6/5. So take away 2 divided by 6/5 plus your c. So when you think of that, you think 2 divided by 6 over 5, well, that's 2 times 5 over 6. It's going to go to 10 over 6, and 10 over 6 goes to 5 over 3. You can do more work in here to get to that, but remember, flip it and you'll get 10 over 6 and then simplify it down to 5 over 3. Okay, so the main things to remember here in integration are similar to differentiation. 1 over x cubed is the same as x to the negative 3. Therefore 3 over x squared, taking the x squared up, you get 3x to the minus 2. 1 over root x can be changed to 1 over x to the half, and then if you take that up it becomes negative a half. Think of this one as a quarter times 1 over x to the 5. So that's a quarter x to the negative of 5. And we must be good with our roots and powers. The root always goes at the bottom of a fraction and the power at the top. So this bit becomes x to the 2/3, and then when you take it up the top it becomes negative. Sometimes you see integration like this. Now really what's happened there is the dx's went in the top instead of a 1, so when you take that down the side you really get 1 over root x there, dx. Now root x is x to the power half, so you take it up and it becomes negative. So instead of having 1 over root x here, you can take the x up to the negative a half. Add 1 to the power becomes positive a half. If you take negative a half and add 1, you get positive a half. And then divide 1 by a half, like this, plus c. So 1 divided by half is the same as 1 times 2 over 1, so that's 2x to the half. Again, you could take it further and say that's the same as 2 times root x plus c. If you have brackets like this, then multiply them out just as in differentiation and get all your terms individually. So to multiply this out, you're going to get t squared plus 5t, another 5t, and a 25. So that's going to go to this, t squared plus 10t plus 25. Now you'll see in this example I don't write the integration sign every time. So integrate this, add 1 to the power and divide, so a third t cubed. Add, this is t to the power 1 really, so add 1, it's a 2, and then divide, so that's going to be 5t squared, and the 25 becomes 25t plus your c. Last example here, we set this one up the same as we would if it was a differentiation question. The way I do it is I split it all up into individual fractions, so it's n over n plus root 3n over n plus root 4n over n, and change your root 3 sorry, cube roots into thirds and your fourth roots into quarters. So end up looking like this. Then we just use our laws of indices. N over n is just 1, so that's integral of 1. N to the third divided by 8, this is just a 1 there, isn't it? Really, n to the power 1, so we've got a wee 1 here to signify that, and so is that. So we've got a third take away 1, because the laws of indices say that when you divide you take them away, so that's going to be negative 2/3. And a quarter take away 1, that's negative 3/4. Now we can integrate. So integral of 1 is just n. Add 1 to the power, so that's going to be negative 2/3 plus 3 over 3, so that goes to 1/3. And divide by a third, so 1 n to the third divided by a third. Add 1 to the power here, so you're adding 4 over 4, so that's going to be a quarter, and divide by a quarter, plus c. Finish it off, you've got n a third, 1 divided by a third is the same as 1 times 3 over 1, so 3 n to the third, and 1 divided by a quarter is the same as 1 times 4 over 1, flip it over, 4 n to the quarter, plus c.